Okay. So please write for me viscosity. Viscosity. We know that this is under physics 107 now, practical, what we're doing today. So we'll try our best to even plot graph today. So I want to use my hand and teach you how to plot graph today. So viscosity. You say that viscosity is the measure of the resistance. The measure of resistance offered to the flow of fluids. Viscosity is said to be the measure of resistance offered to the flow of fluids. So we know that fluids are things like gases and liquids. So we say it is the measure of resistance offered to the flow of fluids. Another name for viscosity is fluid friction. Fluid friction. Another name for viscosity is fluid friction. So the way you normally say friction in normal day-to-day activities, when you hear friction for fluids or anything that is liquid or gas, that name is what we call viscosity. So, but this viscosity deals more with liquids. So you see that in most cases they don't put gases there. So I want you to have that in mind. So if I know that for the fact that what we are doing today is your practical, that is determination of viscosity using Poiseulles method. So what this man did was to get, I didn't hear you. Okay, I said what he did was to get a tank that has water, and he tried to immerse. I believe in your practical book you will see what I'm drawing here, so that you don't judge me by the drawing. So he immersed a capillary tube here, so that you can adjust or still you can increase it or adjust it. But when you are doing this practical, you always see something like this. Let this be the water source, filled water. You will see calibrations inside this. I posted the practical on my channel. So if you watch it, you will understand it better. If you've not done the practical. So I just want us to try. Now when you see this, you now see that the same way it's calibrated here. Let's make room for opening. Let's say it stops here, please. Don't judge me with the diagram, but get the point. So you now have so what he did, please, what he did is to pour in water inside this tank, and he made sure that the capillary tube he used was placed horizontally, not vertically. Why? This is part of the precautions you give them in case for exam. Why he placed this horizontally and not vertically is so that one, he avoid the effect of gravity. Very important. So horizontal placement of the capillary tube in order to avoid the effect of gravity. Number two is that he ensured that the water dropping, once he on his watch, I will explain that one, but once he on his stop clock, he made sure that this water continued to drop. So it's not like maybe as he on his stopwatch, some parts will drop, it will no longer drop, no. So he made sure that there is continuous flow of the liquid. And three, he also made sure that the liquid he used is a distilled one, a distilled water, a distilled liquid. So please, these are part of the precautions you need to take note of. Now moving on. He now, in doing this practical, I know you've done it, but let's just explain. In doing this practical, let's say we are told to check the volume of liquid in let's say a minute. What he will do is, he will on his stopwatch. The minute he on that stopwatch, he will open this tap. There's something like an should I say, you see a tap, a controller, or a switch, a controller. So the minute he on his stopwatch, he opens this water immediately. So let's say for 1 minute, this water will be dropping. It will be dropping. It will be entering here, be dropping. While the clock is reading. Once it gets to exactly 1 minute, he will off this water, then off the stopwatch, the same time. Hope you're getting it.
Yes, sir.
So when he does this, he checks the time. That's 1 minute, because already you know that what you are looking for is the drop, the amount of water that will move from this into this in 1 minute. Assuming you're using 30 seconds, the same thing. Now, when he finishes this, when he off this stopwatch and off the water, he will now carry this to a flask or a cylinder, a measuring cylinder, and whatever. If you don't use measuring cylinder, but we are talking about Poiseulles method, and that's what he used. He goes to a measuring cylinder, and this is calibrated in centimeter cube. It's calibrated in centimeter cube. So remember, we are just trying to have a mental overview of what we are doing before we start solving the questions. So, okay. So when he goes into this flask, he carries the water, whatever amount of water here, he pours it inside here. Now when he pours it inside here, whatever measurement he's having, he takes note of that. He will write it down. This is the volume. In a particular 60 seconds, which is 1 minute, this is the amount I got. Let's say the water was here. This is the amount I got. What will he now do again? He will take his meter rule now. Measure the height. You know that if this is the tank that poured in this water, if the water was here, after dropping this one, it will reduce. Is it not true? He will go back again, take his meter rule, measure the new height. Now when he measures the new height of this water in this tank, he will go back and on his stopwatch. 60 seconds, that is 1 minute again. As this is entering, he's looking at it, was he gets to 60 seconds, off the stopwatch, carry the water, pour it in here again, check the measurements. You can decide to say, as he was doing this practical, he even changed time, it was not stable. So you can decide as you're doing your own practical, depending on the examiner, you can decide to have maybe 20 seconds as you're doing this. So you still measure the height. So the key thing about this practical is that you are taking note of the heights. You're taking note of heights. For each exercise you're going to be doing, or each timing you're going to do, you're going to be taking note of the height, and you're going to be taking note of the volume. And it is going to be in centimeter cube. That is the calibration. And we know that when we finish this, we should convert to meter cube. This one is going to be in centimeter. And we know that when we finish this, we should convert to meter. I hope I'm not confusing anybody. Because we've not started anything. What I'm just trying to do is to create a mental picture of what the practical using Poiseulles method is. This is not the only method of determining viscosity. We have the Stokes method. We have just capillary tube action. But it now depends on what you are asked to do. And if this is your practical, if you look, they told you to use Poiseulles method. So that is why we are using this. So I said, listen to me again, let me summarize. I said, when you have that water in that tank, you are first of all going to take measurements of the heights with your meter rule. From this point that this water is filled up, you are not doing from table, you are checking the amount of water in here, the height. Now when you do that, you allow this water flow after on your stopwatch. Let's say you want to do this practical, you want to check how much water will enter here. In 60 seconds. Do you know why? You are checking the viscosity. The reason being that in an ideal case, water must have friction. There must be resistance to the flow. So what you are checking is in 60 minutes, as this water is dropping here, how much of it do I have? That means that if everything being normal, in 20 seconds, I should have lesser water. Is it not true? In 60 minutes, I should have more. But when you finish, you are now comparing the 20 seconds and the 60 minutes. What happened? Was there friction at some point after I passed maybe 30 seconds or thereabouts? So the proper reason for this is to check as water is flowing. Is it really flowing very fast? What are the factors like temperature? Did it make it slow down or was it very fast? So the goal of this is still having in mind that whatever liquid we are having has a resistance, that is to the flow. There is flow resistance. So that is the goal of every practical we're doing under viscosity. to check the flow resistance. How much of water is entering. You can't tell me that if, for example, I use engine oil, maybe my engine oil or brake oil, and I choose to come and pour it here and I start checking this thing. You will not tell me that the amount of engine oil that will enter here will be the same amount with the water that will enter here. Hopefully it's not possible. Yes. Reason being that engine oil has more resistance. It has more viscosity. So that is just the goal, the essence of this class. So if that is said, we now summarize. We will still derive, okay, before that, and because I want us to do the graph, we need to note this. You need to note that he derived the formula I'm about to give you using pressure equals to F over A. And we know that means that if I make force of the formula, it becomes PA. Is it not true? And we also know that Isaac Newton, said that force of attraction is directly proportional to what? Those of you there, can you see? So Newton said that force is directly proportional to area, Shebi, and velocity gradients. Do you remember? Now, when I introduce equality sign or proportionality sign, I now have equals to, I will introduce this. Shebi? Then I now have AV over L. Trying to make this result of the formula, I'm going to be having Shebi? Do you agree? Okay. So, and it is from this, we see that this thing here is pressure, don't you so? And the unit of pressure is Pascal, right? This thing here, notice something. This one is L, this one is L, this is L. We are not in a hurry, in as much as we want to do practical. This is L. All over. Velocity itself is displacement over time, Shelly. Do you agree that this thing is the same thing as saying L divided by S over T? Do you agree? Which means that this is the same thing as L times Shelly? This is in meter, this is in meter. Do you agree? Which means that I'm now left with Pascal and time. So this is why we normally say sometimes that the unit of viscosity is Pascal. You guys see what I'm doing? Is it that I'm blocking you? Yes. Or it's too small? Okay, it's low, sorry. Wow. Hey. That would be another factor. There's no once you come, one of us should be sitting here. I can see now. Yes, it's garage. Forget it. So please, see, I said, I'm just trying to get this unit for coefficient of viscosity. But let that not worry you. I said we are going to derive this. And I said he got his formula, the formula he has, using these two things. That's Newton's law, that is force directly proportional to area and velocity gradient, and that of, let's call this one, pressure. We know that pressure is equal to force over area, should be? So at the end of the day, he gave us, can I come in? Yes. Remember what I said here. At the end of the day, he gave us a unique formula, and this unique formula is simply us having, when I have 8 and viscosity gradient all over pi r4. So please, I said we have pi r to the 4th power all over 8n times pressure gradient. Hope you know that this is pressure gradient. You see? Shemi have told you before that anything gradient means that divided by length. Acceleration gradient is acceleration divided by length. Velocity gradient is velocity divided by length. I did not say velocity time gradient. If I say velocity time gradient, that means I'm talking about acceleration. Is it not true? But only velocity. Anytime you hear gradient of anything, it's simply over length. So this is what first here gave us. It gave us needs to be pi r raised to the power 4. If I put this, it becomes p all over 8. This is viscosity coefficient. Hope you know. Yes. L. But whenever you want to quote this, I want you to look at it from these lines. So Poiseulles' law. Okay, ask. You don't understand it. Why? Okay, you don't understand it because I rushed it. I said that force there, first of all, we know that from pressure, we'll get that pressure is equal to force over area, should we? Now, I said that Newton said that force on a liquid, force of attraction you have to the liquid is directly proportional to the area and velocity gradient. Now, when you now introduce equality sign, proportionality sign, anytime you hear directly proportional, when you now introduce equality sign, you should not introduce that particular thing you're talking about. So, attraction in liquid and the resistance there is simply talking about the viscosity. I told you about function. So, we now introduce viscosity coefficient, which is that n there, that extended n. So, you have this. Now, please, I want you, since we're still talking about the practical, I want you to know that this P, please pay attention. If you don't understand, you see this one here, don't worry about it. I'm trying to derive the unit. If this is the problem, we have no business with that thing. If it's confusing you, this is where you should be. That viscosity coefficient is simply this to this, this to this.
So that time we say P over L. What was that thing?
P over L.
Yes, and you said P over L that we
You said?
You said once we see P and something, you know it's P over L.
I said once you see anything over L, know that it is that thing's gradient. If I see velocity gradient, it's simply velocity over length. Time gradient T over L. Mass gradient M over L. Whatever gradient, U over your length. Can you see that? Yes. Let me see your practical manual, the page ahead. So you see, this thing that I drew, it might not be looking sweet, no. I need a new one. And I've really... But I think the new one and the old one are really the same one. Who is the parent? Who is the medicine here? Who is the medicine? Which one is medicine using? Calm down. Calm down. So see, notice something, please. Notice something. Can you see? Don't worry, we'll use the two. But the truth is that I've observed that they're almost the same thing. Notice, Shebi, we said that this is Poiseulles. I use P for Poiseulles, Shebi. Now, this Poiseulles law is also called the volume flow rate rule. Or it's a volume flow rate method. So I will replace this Poiseulles law that I put here with V over T is equals to. Can you hear me? I said Poiseulles method is simply you determining volume flow rate. That is volume at a given time. That is why I will have to on my stopwatch allow liquid to flow. And you know that anytime I'm talking about liquid, it's volume. Should you know? Allow liquid to flow. Now, when this liquid flow at maybe a particular time that I'm checking, I will stop the stopwatch. Then I come and carry the liquid and check the measurements. So the only thing I'm just doing is for each one, as it's decreasing to give me that liquid that I'm measuring, I'll be checking the new height. For each of them, I'll be checking the new height. So that is why we said that Poiseulles rule is also called the volume flow rate method. So all I'm going to be doing now is, instead of Poiseulles, I'll be replacing this with V over T. And if you go to some advanced physics textbook, because I know some of you in physical science, as you go to advanced physics textbook, you see that this V over T sometimes, they replace it with just Q. Yes, as you progress. So if you see it as just Q, the mistake you have there is that I notice in your textbook they are putting just V there. And it's wrong. If I put just V there, you will think it's just volume I'm talking about. So I'm not going to be using volume, V there. So it's either I use V over T or I am using Q. So Q is the same thing as volume flow rate. So it's equal to everything there. Pi R4, then B all over 8 coefficient of viscosity times L. Now I wanted to say something before I forget, please. We have not started solving the question. I just want you to understand. If you fall short, call me back. I want you to know that if I'm okay, fire. This one now. Okay, see what I'm saying. See what I'm saying. He said that we have a 22/7 constant. I know where now, class Armand dismiss. That's advanced engineering. We have to do differentiation and integration. He said there is a constant 22/7, and that 22/7 has the radius 4 times, and that it is divided by 8. That is the constant. Now, I am passing it with coefficient of viscosity. Everything here is the same thing with what I have here, because pi is 22/7, is it not? Yes. So, R is powerful. Now, I'm saying to make it easy, you will now remember that it is times pressure gradient. Do you know that as I have that my apparatus, the tank, and the capillary tube, as I have it, if you notice, you see that if I have this to be the tank, that space you see in between, you simply put here so that as I finish allowing this thing flow, I can decide to adjust this thing up so that it is no longer touching ground, adjust it up so that maybe the water level will move down. Or if I put it down here so that the water level will move up. So that is what this thing you are seeing in between is doing. So if I choose to allow this, and I don't want you to even think about this thing inside, that's not your problem. Where your problem is on the water flowing, the water that is flowing. If there is not enough pressure inside this thing, hope you know that this water can decide to go like this and be coming back. Yes. Are you aware? Yes. That means that the initial pressure must be more than the final pressure. If there is no enough pressure to make this to push out, that is the second pressure, water will not flow here. It will just, if they are equal, it will just come back, come. So there should be enough pressure. And why would there be enough pressure? You notice that water here is having a higher concentration. Are you seeing how the bigger area and having much more water means that it has more concentration. And you know that another name for pressure is concentration. Are you aware? Yes. If I have so many people inside here, the concentration increase. Pressure will be on you for us to go fast to leave this hall. You are feeling hot. It's true. So that is pressure for you. So if I know that this particular tank we are using alone, I can't use a smaller tank. It must be something bigger than this capillary tube. So which means that the B1, or you said the initial pressure, is going to be greater, or is a must greater than the that is the final one, that is P. You know that this P naught means initial. So P naught must be greater than P. So when I see this pressure gradient I'm saying here, another way to put this thing is simply you saying, this is not part of the work, because we're supposed to have done practical, we just come. We do and go our way. So another way to put this is simply to say that volume flow rate is equals to pi R4 all over 8 coefficient of viscosity. I normally write mine like this. Then times change in pressure gradients. Are you seeing it? Yeah. So it's not just what pressure you are looking at. You are looking at the initial pressure and the pressure that will let the water out. That is the final one. So if that be the case, it's the same thing as saying that this is pi R raised to power 4 all over 8 coefficient of viscosity, and this is the same thing as saying B naught minus minor P all over L. So please, you can just come into the hall, you see a case where they want to confuse you, they purposely tell you final pressure, initial pressure, and because your mind is always on that anything change is the final one minus initial one, you gotta be putting it sideways, you will fail it. So have that in mind. The initial pressure is minusing the final pressure, because the initial pressure will always be greater whenever you are dealing with Poiseulles method. So if I know that another way to write this is this way or this way. So volume flow rates all over equals. Another way to still write this is to remember up thrust. I normally tell my students that whenever I will still teach you up thrust, that whenever we talk about up thrust, it's simply that force that tends to pull that thing back up. and that it is equal to the amount of water that will be displaced. Shebi? I now told my students that another way to judge upthrust is to simply say that it is the work done in liquids. Yes. So when I start teaching you, prove all these things I'm giving you. So if that be the case, I know that we have something like this, which is height. This P is density, and this is G. Now let's check something. Let's compare this. Do you know that? I feel like I'm giving too much information. Please, we understand this, Shebi?
Yes.
Do we understand up to this extent?
Yes.
Okay. Ngwa, let me clean this. Let's just check something. For everything Poiseulles law or Poiseulles method, once you hear volume flow rate, and another way to know that it is Poiseulles law you're talking about is that if you don't hear volume flow rate, or you hear mass flow rate, you know that you're talking about Poiseulles method. Can you hear me? That is why when I did this formula, I first wrote Poiseulles here. Then I now told that it is the same as this, because that is just what the practical is all about. That is just what this practical is all about. So I now said, see what I said. I said, if I have height, and I have density, and I have G, does this thing look like any formula we've encountered before? Yes. What is that formula? MGH, Shebi? Is it not looking like it? Shebi is looking like it. Mass, gravity, and height. Shebi? And do you remember that this thing is F, and this one is H? Do you agree? Yes. So that means when I have height instead of displacement, that means it is not this way but this way. Vertical. Shebi? Which means that this thing is the same thing as work done. Just work done vertically. Do you agree? And we know that work done vertically is the same thing as potential energy now. Hope you still remember. So if that be the case, I know you want me to say it's something as work at rest or energy at rest or body at rest. We have to think as physics students. So different dimensions cause for us remembering that this can work here, work here. So if that be the case, and I remember that density naturally is equals to mass over volume, Shebi? Yes. This volume, we can have a case where density is equals to mass over length. We can have a case where density is equals to mass over area, depending on the surface, but it's always mass here. Which means that density, which is represented as rho, is directly proportional to mass. Is it not true? Yes. When we start doing upthrust, if you refuse to view density as mass, some things will be confusing you. To continue to confuse you. So that is why we are saying that whenever we are dealing with liquid, that the pressure there, or the upthrust there, is considered also to be work done in fluids. So this simply means that if I'm considering this density as directly proportional to mass, I'm considering this to be height, I'm considering this to be gravity, that pressure also can mean the same thing as work done in fluids. So which means that there can be cases where, as I come here now, remember the time we started, there are some cases where I can come and I see that this volume flow rate is equals to pi r raised to the power 4 all over 8 viscosity times, instead of having P, I'm having now all over L. So there are cases where I'll come and see this, and there are some cases where I can see it as changing, but you don't see it in most cases. So what I'm saying is that this thing, everything here is the same thing with this. So you need to just go and notice that in fluids, that I said, in fluids, I know it might not make sense to you proper, but that is why in Physics 101 I'm going to be teaching you fluid mechanics. It's in this fluid mechanics I'll start from the beginning to teach you everything about fluids, both the laminar, both the turbulent too, what does it mean. Then I'll now move on to be teaching you things like upthrust, what does the Archimedes principle. It's in fluid mechanics. We're going to do it in this 101, not 107. So please, another thing you need to note under the precautions you took during this practical I forgot the fourth one, is that the liquid you use, the liquid you are using must be laminar and not turbulent. It must be laminar and not turbulent. When you hear something is turbulent, it means that on a water, like agoto, sorry. But when it has to do with laminar, it simply means that the liquid must be flowing straight, continuous. You understand that? Yes. So the liquid has to be flowing straight, continuous, linear. So it's not you don't use boiling water to do this kind of experiment. So you need to have that in mind. Add it to your fourth precaution. Another thing I want to touch, because as I'm trying to teach you this, I'm also having that in mind for the sake of your exam. There's something we call percentage error. I don't know if you've come across it. Remember in our last class we did standard error, Shiri? Yes. So today we'll try to touch error. Then percentage error. In our last class we did how we get our errors. So if I hear percentage error, can I claim? No. I'm going to be fast. If I hear percentage error, let me start with error first. Whenever I hear error in anything, I do not say standard error, because I know that if it's standard error is simply gotten by doing degree of accuracy divided by 2. Do you still remember? Yes. The degree of accuracy of anything. For example, if somebody asks me, what is the standard error of meter rule? I will tell the person, first of all, meter rule runs from 0 to 1. In between, we have 10 lines. I will do 1 divided by 10 equals to 0.1. Shemi? This is the degree of accuracy for a meter rule. Except when they tell me that maybe the standard error of meter rule, I should take it as 0.1. That's when I can use it. But naturally, the standard error of meter rule is simply this degree of accuracy divided by 2. If I want to do for maybe vernier caliper, I know that vernier caliper has, first of all, this degree of accuracy to be 0. Shebi? Yes. That's the degree of accuracy because it has main scale from 0 to 1, which is 10. And when you do that, then you are having this one of meter rule. And this one of meter rule is still being divided by 10 inside vernier caliper. So that is why we got this. If you are not in our last class, you missed a lot. You stay recap, but try to follow us. Say that I said the degree of accuracy for a vernier caliper is 0.01. Divided by 2, you get what? 0.0. Like this. For those of you new students, panic not. So, but what we are saying now is that that is for standard error, dividing the degree of accuracy by 2. But when it has to do with error, you don't get it like this. There is difference between something being standard and normal. So, by standard, like a rate, a judgment figure, that's standard. Error, okay, the usual. How do you calculate the usual? So, if I'm talking about error, we simply say that error is gotten by taking measurement or experimental measurement, our practical value minus actual value. And what is the actual value? So I said our practical value or practical measurements. Our practical measurements minus the actual value. So this actual value that we are having here, when we talk about error, can now be standard error or whatever you are given. Can you hear me? So let's say that I know that naturally I know that the standard error of meter rule, when I do 0.1 divided by 2, should be 0.5, should it? Or is it 0.05? 0.05, thank you. If I know that the standard error of this is 0.05, and I did a practical, that is using my measurement, my own measurement, I use my vernier caliper now to measure, do all the measurements, and I got this to be maybe a bit more or a bit lesser. That thing simply means my practical measurement. So I will now use that my practical measurement. Maybe I got it to maybe 0.05, let's say 6 or 7. You see that it has now used small style and now enter 0.06 for the practical. So what I will now do is to simply do, that's my standard or that's my normal error for this. Then or should I say, I minus the normal error from the practical error. Whatever it gives me is the error. Is it confusing? Yes. Okay, but take for example. You know this is not the main thing. I'm just trying to touch all the things necessary because of, as I'm teaching you this, I'm looking at exam safety. But I'm saying, if for example, I did a practical, and in that practical, I got C. Let's say in the practical, I made measurements, and I got that the measurements I have is, let's say, 2.8, and that the actual measurement or actual value I'm supposed to have is equals to, let's say, 2.78 or 74. You see that it's almost close, but even approximate is like this now. Is it not true? So what I'm saying is that error naturally should simply be that measured one, that one of practical, minus the actual one, the one is supposed to be. So punch, go there, let me see what you have. 0.1. There can be cases where it's even negative. Hope you know. Your own is to punch and get the value. That's what error is. But if, for example, they now ask you percentage error, if they ask you what is a percentage error, what it simply means is now, you please, do you know I'm trying to clear these things up? Is that some people, once you tell them anything error, they are wrong to ChatGPT. ChatGPT SD all over root N. They copy all the big grammar and paste it. It's not wrong, though, but by the time you check all those calculations you've done before arriving to this thing, it's time wasted. So it's too much. That is why I gave you a method of doing this last week, and I want you to know the difference. So you don't always, maybe you go and use this one to look for another one. When they tell you error, you are doing standard error. Or when they tell you percentage error, you are doing standard error. It's wrong. So if it's not percentage error, I'm saying that what you should do is simply take the absolute value of error. Take the absolute value of error. Whatever you have as your error, take the absolute value. Now, by the time I've taken this error value, divide it by the actual one. Or you say, Shebi, I told you that this actual value can also be your standard error or standard value. Shebi, I said it. So divide it by the actual value or the actual error. Please be putting things the way I'm saying it, actual value or actual error. However they state it. So you don't enter there and forget which one you are thinking of. So actual error or actual value. Then, you know that anything percentage must have 100 now. Times it by 100. That is it. So if, let's say, I have 0.1 here, assuming maybe what I got here is like negative 0.1. Hope you know that absolute value simply means take this negative away. So I will simply now still go back to having it to be just 0.1 divided by the actual value, which is 2.7, times it by 100. Every practical in this world, whatever thing like with regards to measurement is the same, it stays the same. So you need to note it. Now somebody might want to ask me, how do you know standard error apart from maybe they did not, let's say they gave it to you and you go and you are using this my method. Let's say you enter exam hall inside your workbook. They gave you standard error, but because you did not attend tutorials, you don't even know what is standard error. You go back and said, that man, the man, academic, he said that day, the degree of accuracy meter rule, you do by 2, you should get 0.05. That's what the man said now. This thing is when they did not give it to you. Every practical, in most cases, they always give you the error, but nobody will come and tell you that that is the error. Let's say, for example, I want to give you volume now. They come and tell you Z. Now you come and see beside it, you see plus or minus. They come and say maybe 0.5. This thing never will be your standard error for that practical. Can you hear me? It's very important. And what it means is that the increment or decrement, that is change. So if, for example, I have 2, adding 3 to it is increment. Removing 3 from it is decrement. Shemi? That is your standard error for that practical. You don't need to come and start doing this thing that we're doing here. We only do this when we don't have standard error. So you always check the value beside it. Maybe you have time t. By the side, you come and do plus or minus 0.1. You now, you come and be using that method we used in class that day. And if you notice that method we did in class that day, by the time we did it, it was having plus 0.02 somehow. And we still made it so that the other one will be positive. But if you do it well, you see that the other one gave us 0 minus 0.02. If you do it well. So it should be increment, decrement. So you do this kind of thing when they did not give you the standard error. But provided you are given, no need. This is just your standard error. So with that said, I want us to look at that your table. That is the table you have. Knowing now that Poiseulles method is simply talking about volume flow rate. And anything flow rate or anything rate, maybe if I come and tell you power is work, the rate of work done, you simply divide work by time. Hope you know. The rate of anything is just divided by the time. So if that be the case, I'm now telling you that the summary of Poiseulles determination is simply divide volume by time. Volume flow rate. And how do you do that? By making sure that you are taking the height of every liquid drop. You are taking the height of every liquid drop. And when you are taking that height, for every liquid that drops, you are measuring the liquid. Are you seeing it? At a particular time that you set. You start with the time. Because the time you are using, you already know it. It's not like maybe simple pendulum where you shake it. In 20 seconds, you pause the time. You are now checking what is the time. That is after 20 oscillations, you pause it and you are now checking what is the time. Shebi, this time around, you are no longer checking time, because time you already know the time you are using. But rather, what you are now checking is the liquid drop. You get the point now? Yes. So with that said, let's look at that manual again. Let's try to plot the table so that we don't waste all the time today. Because I want us to still complete our equilibrium class. Then on Monday our practical class, I told you Saturday and Monday will be using it for practicals. On Monday our practical class will be compound pendulum. I believe simple pendulum is very simple. So, and it's even compound pendulum, all these things are already on the channel. For those of you on the paid group, you will notice that I've posted playlist on simple pendulum and compound pendulum. So take your time to go through simple pendulum. That's not what we should be doing in class. It's very simple. Okay. So please have it in mind. It's not even like young modulus. If you notice when we do young modulus, there are cases where we are plotting T squared against L cubed. Shall we? Cases where we are plotting M over L. But for when it concerns Poiseulles method, we are always using volume flow rates and heights. Because that's just what the practical is all about. That is why I'm telling you that there is no imagination to it. Just see it as where you are measuring volume with time and you are checking height for each case. Finish. Okay. Okay, so see here, in this table they gave us volume per 20 minutes. So that means when I'm doing this practical, my stopwatch for each of the practical is going to simply be that I'll on my stopwatch for 20 minutes. That's what it means. I on my stopwatch for 20 minutes. I will take the height of that my container, that my jar at that point. When I get it, and that is why they've given us the height for each one, Shebi? So notice, when I take the height of the container, I am now seeing that. So see, notice again, I want you to check something. Notice again. When I have the volume to be 42.92, the height is 20.0, Shebi? Yes. That is the height there. Then when I have volume to be 150.22, the height there is what? 70. Now, volume of 150 and volume of 42, which one is bigger? 150, Shebi? Height of 70 and height of 20, which one is bigger? 70, Shebi? Which means that the higher that liquid, the more pressure. Is it not true? of pushing it down. Hope you are getting what I'm trying to say. It's number 146 on the old one. So please, for those of you that have the new one, it's still the same thing. Okay, the people with new one. Okay, new one is 105. Old manual is 145, 146. So let me just draft the table.
Yes.
Okay. Did you do the practical? My friend, you did the practical. You did the practical. Did you do the practical? So how did you get your own name good? Okay, what you did is you converted SI units. Okay, I thought maybe you did the practical. So who has done the practical? Which department has done the practical? Okay. Okay, but you understand how it's done now. Please, if you check that my channel, I posted on the channel by 4 today. Check, you see the time I posted that practical on my channel. It was around 4 here about. So try and watch that video. Watch it. This is the very simple practical because it's just one thing you are doing. Okay, please, you will see the link. Now check the group. Are you on the general group? Are you on the general group? Or you have my number? I think that's the I noticed we are starting to have a lot of invitations this year. You're not on a sweet name freshers group. Wow. We are not being very active as usual. Wasi, type my number 090 if you're a new student. 2000. You just come to Barclays, some people will just be saying 2000. 2000, I say you're not feeling fine. Please, message me. Academic daddy. Naturally, once you message me, you should get an auto reply. You join the group. But please, if you message me, you've not gotten the auto reply, just tell me, I've messaged you since, so no auto reply. Once I see it, I will quickly go and copy the link and paste. So please, let's draft the table so that we use our time well today. And I'm thinking, maybe we'll be doing parasitology just once now, every Saturday, so that we have enough time to do physics practicals. Do you support me? No. And the person I gave this table did not do it the way it should, because once you are using 2 decimal places, you should use 2 decimal places throughout. So please, as you are doing your own, always remember it, even when it has to do with units. Okay. One please. From the question they asked us to find the SI units. Shebi? They say we should find the SI units. But please, let's check something. Do you remember that formula for volume flow rate, it is equals to pi R4, Shebi? Yeah. 1 over 8 times Q over L. Now see something. Do you know what this thing means? The higher the pressure, the higher the volume flow rate. Hope you know. That's what it means. Now, the higher the volume flow rate and the higher the pressure, it means that viscosity will be lesser. What you know that viscosity simply means friction. I don't want you to flow. It will be lesser. Now, this is L length. This length, L here, means length of the capillary tube. Notice that if the capillary tube from that thing where the water is coming is longer, it simply means that it will take longer time for the liquid to flow out. Is it not true? But if it's shorter, it will be faster. So please, I want you to still remember that in comparing this, maybe I call this Q, that it is important to note that the ones up means that increase in it means increase in volume flow rate. And decrease in this means increase in this. That is same inversely proportional. Okay, let's go back to answering the question. I almost skipped my mind. So they said, convert the table of values to SI units. One please, have you converted your own? Oh yeah, let's do it as an exercise. We'll be doing each one as an exercise, we'll be doing it together. So try to see if you can convert 42.92 seconds to look at you. Try. We'll do it together, but try, push yourself. It's still part of the things we are going to reteach under minutes and dimension for the new students. It's pencil inside your book, or it's pencil. Don't ever use pen, no. I see some people, they use pen, nail for this book here at the wrong. Pencil, please. Always use pen. Some people come and use correction fluid inside their practical manual. It's just because we no longer have auto lecturers. This particular VC, he pursued a lot of our old men. I used to be sorry. So please, in doing this practical, if it were those days, correction fluid in your manual, they will call you to the office to come and take your manual. Your customer will just tell you, go office, go bring your manual. You can see your name on this list. That means the man wants to see you in his office so that he can come and collect your manual. Yes. But since we've got all the young ones, they are taking it like a boy as well. Play with them now. The way you people are forgetting something in this school, sometimes I wonder. No, don't worry. Let's pity for her. But the way students forget things in this school, sometimes I wonder. Small things, somebody just call your phone, you run out of the class, you leave your bag. It happened yesterday now. One girl just left the class. Coming back, they stole 4,000 naira from her bag. She kept inside class on her seat. They went to the bag, collected 4,000. People are wicked though. And last year, this thing did not happen. We didn't experience such last year. Last year, people will even pick people's phone, bring it and give me. Yes. This year, we've been the one picking phone ourselves. Nobody has brought one. Please. So to convert this, what do I do? Do you remember that 1 meter is equals to what? Shebi?
Yes.
So 100 cm, right? Yes. That means that 42.92 cm will be equals to x meter. I'm trying to teach people that our lecturers not to give you this explanation. So let's use this opportunity. So that means that if I cross multiply, I'm going to be having 1 meter times 42.92 centimeter. And remember, I want to convert to meter. Is equals to 100 cm times x meter. So centimeter cancels centimeter. So 1 meter times this, no problem. Now I will say divide both sides by what? 100. Which is the coefficient of So you can see that this will take care of this. So that x meter is equals to 1 meter times this is 42.92 meter divided by 100. I have here for me. So the x meter will be equals to
0.429.
So which is approximately 0.43. Compare everything, please. Do everything so that you have the SI units. So this one is 0.43 in meter. Do everything using the same approach. Do everything using the same approach so that we move to the second question. Okay, they say meter cube. It's true. It's true. What are we doing? That means that this should have been Chevy?
Yes.
Lord of God. So please, that means you're supposed to be doing for me 1 meter cube equals to this. That means x meter cube equals to this in cube now, Chevy?
Yes.
Oh yeah. No, it's already in cube. Oh yeah. Let's exchange. That means that this is 1 meter cube. Oh yeah. This is 1 million, Chevy?
Yes.
Equals to 101 million divided by 1 million. Somebody will be confusing you. You will be looking at the person finished peacefully. Yeah. Well, so punch it for me.
Jesus. 4.29 times 10 power minus 5. This is how I shape. 4.29. 4.29 times 10 plus minus 5.
Okay, that is approximately 4.23, should we? Okay. 4.30. I hear me good.
4.30.
You people have called me. Huh? Shebi, I got it now. So it's going to be 4.3 times 10 raised to the power minus. I ask. In meter. You said? You see this one? What? No, see. That, this particular thing, please check for me your giving value. The giving value is given to you. The 42.
Time.
Okay, easy. They're saying we should convert to what? SI units, right?
Yes.
That means it should be in meter cube per second. Because what we've done is still in per minute.
Yes.
Shall we know? If that be the case, this is not the right formula to use. When you are converting to 2 units, this is when you are converting to 1 unit to use this method. Can you hear me? If we are converting to 2 units, please, it's not this method to use.
Yes.
Fear not, let me show you the method to use when you are converting to 2 units. If it's 2 units, what I will simply say is, I have 42.92. Shall we? In centimeter cube. Or is it what? And we know that this is going to be, notice so, this is going to be the same as saying times all over 1. Hope you know. Now times, I will look at this and say 1 meter is equals, 1 meter cube is equals to 1 million, shall we?
Yes.
Centimeter cube. So times, I'll put centimeter where it can cancel centimeter cube. So all over 1 million centimeter cube. How far am I tell you power? Imagine when I mine. So I'll put it this way. Now times. The next one is minutes and seconds, shall we?
Yes.
I know that 60 seconds is equals to 1 minute, is it not true?
Yes.
And I know that 3,600 seconds is equals to 1 hour. You still remember? Yes. But we are dealing with this one. So what I will do is, remember that this one is per minute now, all over minutes. I'm going to put that minutes. So times, I'll put minutes here, it will cancel minutes. So I'll say 1 minute, so that minutes can take it, is equals to 60 seconds. So, okay, they gave me 20, shall we? Yes. Okay, but that is, this should be 20 now. Yes. So, no issue. So this minutes will take care of this minutes. This centimeter will take care of this. This 0 will take care of this. I punch it now. I didn't hear you. Which? Okay. Jesus. Sorry. Sorry. Punch. Forget what I did. Just punch. Forget what I did. Just punch. The truth is that I don't want us to be here. I want us to leave this topic and move to something. That is the truth. So let's be fast, please. Pardon. Let's be fast. So you do the rest. Let's move to question 2. My main task is that I've already passed that stage. So the second question there is plot a graph of the rate of flow in volume per second against head of liquid. So please, let's do the graphing. Have you gotten the other values? So that we can write out the values and then we'll plot our graph. We need to be fast. Can I claim? You've copied now. You've done it in your book now. Hey, Jesus. Cooperate with me, oh. There's no time. We'll still do graph and it's lengthy. Cooperate. So they said, plot a graph of volume flow rates in volume per second against head of liquid, that is the height. Yeah. That is supposed to be height of liquid, not head of liquid. Yeah. I'm going to be having, let's say this is my graph notebook. I found out that we don't make use of our time well. We normally stay doing one thing, the whole time will go. So please try and be speed up, be fast upstairs with us. Plot a graph of volume flow rate. So let's say I have this side to be my V over T, and you know that it is in meter cube per second. And this side is height. I know that it is in meter. It's in meter. Hope you know that height too, you convert that height to meter. Yes. So do all those conversions. So let's just solve. So I will be having my table of value for V over T out, and I will be having my table of value for H. So this one is in meter cube per second. This one is in meter. So, give me the values you have. Let me not use one person so that we'll be sure we are correct. So you'll be reading the question one for me. You understand? When I need to read it out. Give me the values you have for the first one. As it's converted, be fast.
3.58 times 10 raised to power minus
3.58. That is 3.58
times 10 raised to power minus 8.
Minus 8. Okay, give me again.
5.37 times 10 raised to power minus 8. Times 10 raised to power minus 8.
Okay.
8.94 times 10 raised to power minus 8.
Okay.
1.07 times 10 raised to power minus 7.
10 raised to power minus
7.
Okay.
1.25
1.25
times 10 raised to power minus 7.
minus 7. Okay. Is that all?
Yes.
Please check if they are correct too. Okay, for the height, I have 0.2. I have this one. Huh? Is that all? Please check. Are we correct? Please, what's the highest value here? Like, your graph has like 12 blocks. Should we check? Oh, like, that right graph notebook has like 12, like 1, 2, 3, 4. See up to 12. I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. But your own, we have the 12 to be the last one. Shall we? Okay, so let's say I have it in here. Let's say. So we know, please. We know that if you look at this one, this side, it's looking as if this one normally has 10, you see, or more. What? How many boxes?
10.
So please, as you are looking at it, that box, as you are looking at it, you will notice it's something like this.
Yes.
So this is like 2 centimeters, 2 centimeters.
Yes.
Give me your calculator. So define the highest value there. The highest value. .25, yes? Divide 1.25 by 14. By 12, sorry. Okay, thank you. Guys here. There is what? One here. 1, 2, 3, 4, 5, 6. How many is this supposed to be? How many observations? 6, Sherry. So check for my. Okay, this one, the next one is this. I have to for me. 0.70 divided by 10. 0.07. See what you have? Right here. Coming.
0.10.
Is that it? I didn't. 1.
5.
Hope you're noticing what I'm doing. Do you know what I'm doing? No. Okay, you don't know. See, in order to get my scale, not like it's always perfect, but any adjustment I'll be making it now, having this in mind. So to get the scale on the vertical axis, because notice that this side is the vertical axis. What I'm doing is to simply say the highest value. And notice that the number of points on this vertical axis is 12. Shall we? So I'll say the highest value divided by the number of points, which is what? 12. Is it not? Yes. So that's the highest value. So if that is 12, what I'm going to, if I divide by 12, it gives me 0.10 times. It's not even 0.10 it's giving me. It's giving me.
So you didn't add times 10 raised to 4.
Yes.
You didn't add times 10 raised to 4.
I'm coming. Yeah, no, I'm coming.
1, 2, 3, 4, 5, 6.
So yes, it's supposed to be 1.04. Now we're using two decimal places, shall we? Times 10 raised to the power minus 8.
Yeah.
And you agree with me that this thing is the sentinels. Please look, oh. Okay. You are not seeing the board. You can't see the board. See now. Is this thing the sentinels? 0.000000. Five, six, seven. 1, 2, 3, 4, 5, 6, 7, 0, 10. 1, 0. Let's check something. 1, 2, 3, 4, 5, 6, 7, 8. No. It's supposed to be here. So 1, 2, 3, 4, 5, 6, 7, 8. Please. This and this, they are the same, right? But please, I believe there are some students that this calculator is new to them. And when I'm teaching, I always try to have in mind that Jesus came for the people that are not saved. Shebi? So the saved ones, we are together. But the unsaved, we really need to help you. So please, in your mental frame, when you are adding something here, for every point I have on this from 0, I add this to it here. I add this to it, to what I have. You see what I mean? Do this thing now 2 times for me. Add this twice. What do you have? Times it by 2. What do you have? 2 points. Notice, so this one is the first one that has 0.104. Shebi? Sorry, 1.04 times 10 raised to the power minus 8. Oh yeah, times this thing again, this particular value by 2. What do you have? 2 points. Minus 8. I don't know if you are seeing what I'm doing. So the principle is simply, I've divided the highest value by 12. So I'm now times each of those, that smallest value that he gave me. It's because you're not paying attention now. See, the highest value, the number of values here is how many? On your graph. The vertical is always 12, Shemi. I said, what's the highest value of this vertical axis? If this one will confuse you, like adding this one will confuse you. You are using what? What are you using? Are you using this? This is what I told you to come with. That one you are using is 11 CS. I'm using the one that has force of 22 CS. So please, I said. What is what? Listen to me. Hello. Pay attention. Can you hear me? I said, there is no what if. Pay attention to what we are doing. Getting this scale, this is the first thing you do. If after doing it, your graph looks small, that is where you can now go and say, okay, let me no longer use this method. Let me now start doing the method of making sure that my graph, because your graph should cover more than half of the graph notebook. So what I'm teaching you is how to pick a scale first. I'm not saying there is no what if. The highest value you have on your vertical axis, divide it by the number of points you have on your vertical axis. I've divided and I got the Shebi. The first one, this is 0. 0 plus this, plus that thing I have it here. I now said that value I have, times it by 2, what do you have? You get me this Shebi. Times it by 2 again, sorry, this one that you have now, times it by 3, Shebi. That is the 3rd point. This same value now, times it by 7. 3 points.
1, 2 times 10 raised to the power.
10 raised to the power. Oh yeah. This same thing I have, times it by 4. Who gave me the calculator? There is no what if. And say, listen to me. See. The same question you want to ask is what she asked. I asked. What if you do what? You change this one. That is 1 minus 8. Why? Please. Hello. Listen to me. This thing that they gave us, this is what they gave us inside the book. Is this what they gave us? But you got what you got from converting what is there now. We are using what we have now. I get where you are going though, because that one is in 10 raised to the power minus 7. The other ones are integers power minus 8. That's what you're saying now. Me, I'm saying that by the time we use this thing now and go on, this thing should be in between what we have on our graph notebook. It will still enter. Let's just do what I'm doing now. When we finish, when I check the correspondence with what you've done. So please, do for me. Add this times 4. What do you have? 4 times 10 power minus 8, you mean? But do for me the same thing again. 5.20, Okay, well, this is the 6 points. I do for me.
6
times 10. Do you know why I don't like using magic in some things? There are some things you do magic on. By the end of the day, you see that you put yourself in trouble. So I like using the normal method first. If it doesn't work, I now start doing the manual. We've said it before. Oh yeah, do 8. 8.32, Oh yeah, do the 9. 9 points. Thanks. You see what you have?
Yeah.
Wow. 10. Do 10. 1.04 times. Okay. Now do for me. That same thing times the this Shabi is the 11th point now.
Yes.
Times 11. 1.44.
144.
Okay, sorry, Okay. I do for me times the 12.
1.2 times 10 raised to 1.248
times 10 to the power minus.
That is 1.25 now.
Yeah, that's it.
Times 10 to the power minus
7.
Okay. Okay.
Is it necessary that we must follow like I don't know my
Please, do you know the problem you have? Do you know the problem you have? Using your secondary school approach here in the university. The way you fall. Have you seen a student that failed year 1 before? You put one student who failed year 1 before. That student will automatically become Bill Gates. Do you know why? You just be calling people from nowhere. Sir, please, anything I can do. Sir, please, anything I can do. And me, naturally, once you call me that kind of call, ask anybody, they will never, I'll tell you, nah, I don't know that kind of road. It's either you go to your lecturers and talk to them. Reason being that you don't know who is there recording that conversation. That's the truth. So please, I will advise you, when it concerns your practicals and your parastology, don't use your secondary school approach. Just use what I'm giving you now. This is what we call the way we do it in the university. Assuming I finish this thing now, and I start, that is why you call it practical. It is expected that as you are doing this, you become so fast that if I notice that, if I notice that it is not giving me a graph that is higher than what I expect, like higher than half of this, I can now make room for adjustment, and that adjustment is what we call manual. So I'm going to be pushing things by magic, but by right, you must do it the normal procedure to be sure that you know what you are doing. But ask, you raise your hand, ask.
Now 1.04 times 10 raised to the power minus 7. If you multiply it by 2.
I can't even hear you. You see this one?
1.04.
Which one? No, it's not here you are looking at. That means you are not in this class. You've not been in this class. See what we did though. We said we have how many points here? 12, Shebi? Can you keep quiet? As I'm teaching, people are teaching their own. See, we have 12 points. Divide the highest one by that 12 points. We now said, this thing now, apart from the ground one that is 0, come and do this times 1. That is for the first point. It will give you the same thing. I write it. The second point is 2, Shebi? This thing times the second point, 2. It will give you something, and this is what it gave us. This is how I'll be doing this value that I got by dividing this by 12. Till I get to the 12th point, that is the last point, I'll times it by 12. So there is no point, I did not do this one. What I got here, this is actually the 10th, Shebi? So what I did here is just this thing times 10. That's just what I did there. For us. Does it mean what? That means you're not understanding what I'm saying. What we are doing here is scale we are finding. Hope you know. It's not like guessing scale. You are not guessing scale. That's what I'm saying. With this, you are not guessing scale. So why? This is the method of finding scale. So when you get scale, is when you've now finished this. And you notice that the graph is giving you, like looking at your graph notebook. You check the points. Like I see this now. The lowest point here should be this one, should be. This is the lowest point, you see that? And this is the highest point. So my lowest point in 1 still falls around somewhere here. You see that true? So it covered about from here to half of this graph. I'm using this. So most times it covers. So when I am going to be using that your guess, maybe after doing this, I notice that the lowest point is maybe somewhere here. You see that it did not cover half of the graph. That's why I can say, okay, let me use this one so that it will be expanded. This is the actual method of finding scale. To find scale, this is the method of finding scale. You said? How will you find all the values not there? You will find it now when we start. All the values not there, you will find it. The main thing is let's start. Oh yeah, see. Check for me. Any other question? You must keep writing. Oh yeah, check for me. The highest value here, you see this one?
Yeah.
But divide it by 10, what do you have? 0.07. Somebody called me. Okay, this one is confusing me. 0.07. I said, if you divide this by 10, what do you have? 0.07. So let's go to the horizontal axis. It's not confusing now. So I'll come to the first one. It's 0.07. 0.114. Sorry. Okay. Now look for me. This thing times 2. 0.14. That's something times 3. 0.21. Yeah. Okay. That's something times 0.28. Okay. This is what we say in this pencil. 0.35. Now check again. Calm down, be here. Calm down. See. Let's look at this now. This is where you need to apply the same principle I'm telling you about. Notice that the lowest value here, the lowest value there is 0.2. Thereabouts, Shebi? Yes. Now notice that my 0.2 is around here. Shebi, you see that it is now not more than half of this. Are you seeing it? So for this kind of case, what I will then decide to do is to say, since each of these boxes is 2 cm, let me try 4 cm. Are you seeing it? So let me clean this now. If you like, pay attention. If you like, replay it. So let me now say, I'm coming up. Let me now say, from this point to this point is 4 cm, 4 cm. If you like, let everything be joke to you. Once you come here and see them, let them become your best friends. You'll now be telling your mom, my best friend is playing. Now see, let's say something. If I have 0.07 here, watch it. Please look at this. This now, if I times it by 2, this is the first point to 0.1. What do I have? 0.14. Let's check something. If I times it, this thing by 3, what do I have? 0.21. Okay. This same thing, if I times it by 4, 0.28. Okay. If I type, notice it's not entering. Let me use 3 here. It will not cover the 10 points now. So if you observe and you are not seeing the reason, I said you use the normal method before now trying to do your adjustments. This is what we call the method of choosing scale. So now let's say instead of this now, if this is 0 points, if this is 2 here, that means here should be 3 here. That means from here to here should be another 3 here. That means then that means okay. But notice what is remaining is 2 centimeters. Let's just check, yeah? I have 0.07, Shemi? Yes. Then times 2 is what? I have
0.21.
Okay.
0.28.
Okay.
0.35. 0.42.
0.40. And my highest value is what? 0.7.
Yes.
0.7 is my highest point. Okay. If 0.7 is my highest point, that means that actually 2 centimeters should work.
Yes. Oh, you said no.
I did not see that 0.7. I was looking at 0.7. Pardon. Well, let's go. 2 centimeters, sorry. But it's good we did it. And you now see any case where it happens that you've run out of something and it's having half. You've now seen how to go about adjusting. It's still good. So this is 0.07. Shall we?
0.47.
0.21.
0.28. 0.45.
Hope you know what you are doing. This is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So 6 times 0.07.
0.4.
So 6 0.7. Alright. It's alright, so we can manage this. Yes. So please, that time I was teaching it, I don't know, something just touched my brain. The 0.2, I was just seeing it as the last thing. Don't be offended. So at this junction, we've learned how to find scale. What I will now go and do, remember we always tell you to write dates and what the graph you're plotting is all about. So I'll say a graph, and you know, if I'm using capital letter, I don't have to start underlining it. Of volume flow rate against height. And you know that when you write this one, you should put meter cube per seconds. Then you put meter. Very important. I'll write my dates. Then I'll remember to write my scale. So here I'm using 2 centimeters. It's true. 1.04. And here I'm using 2 centimeters. It's true. It doesn't mean that everybody must use the same thing, but provided you're in this class, if you're not making adjustments, there's something we call having a good foundation. So when you now have this foundation, if you don't want to use our own scale, as you look at it, you feel like maybe it's looking clustered ahead. You can now be making adjustments with regards to what you're doing in line, not too far and not too close. So, but the main thing is understanding the foundation. How to go first. So now let's now go to the table. Where I have, okay, well, ask me. Yep. We need to be fast, though.
Like my skill, I measured the possibility, I measured it to give me 1.5 centimeters. So in my scale, I'm writing 1.5 centimeters, whatever.
Okay, wait, in that's your. Okay, you measured from here to here.
I measured from here to here.
Okay, the first box to another box. Let me see. You.
But I'm asking that it's correct.
No, please. Let me see. You measure from here to here. I get 1.5 centimeters. Are you sure? But have you asked the lecturer what he considers each box? Okay, you ask. Okay, see, see. Do you know that how we do this practical is that I is used to judge. What do you know? I is what they use to judge. So if you measure that and it gives you 1.5, use 1.5. Centimeter is yes. Right? If you measure it and you get 1.5, use 1.5 centimeter is yes. These people were using their own as 2 centimeters. Generally, you know that big box, that is good. Yes. So please, I is what they use to judge. So please, how do you know you're using sharp pencil for your work? Because some people's work, see some people's line of best feet. When they have their point, see some people's line of best feet. What is this, Rickon? Why? Oh, this is when you do forex trading so much. You can't draw line again. Okay. Okay, do you know that? I seriously noticed that each two box in your graph is exactly 1.5. Now is 1.6. And again, yes, and again, when you check it there, if you do it like that 1.5, it's not up to 10 boxes, it's like 9.5 boxes. Wow. That means you work with what you have now. Okay, look. That means that what you are going to be doing here, if you really want to pay attention to this, what you are going to be doing is, whatever you have, you divide for your horizontal, you divide by 9.5. Guys, measure it. Let's check. That's 1 box. That small box is actually 1.8, not even 9.5. So it should be, let's check. If I do 9.5 times 1.5 times 9, check. Sorry, check 1.6 times 9. What do you have? 14.4. Okay. 14.4 plus 1.8. 16.2. 16.2. That means instead of the other one is yes, divide that 16.2 by 2. Divide 16.2 by 2. 8.1. That means actually, if you do this by that 1.5 with the remainder, what is actually here is 8.1. Remember, when you do 2 centimeters in that box, 2 centimeters times 10 is actually 20 shillings. But we are considering it to be that is just one row. So what it means is that actually this to this point, what you are dividing everything you have is by 8.1. I don't know if you get what I'm saying. Please see. I am teaching you in line with this graph. Can you hear me? Now, what I want you to do when you learn what you've learned is that as you are now plotting your own graph inside this, you are using initiative, smart work, and coordination to do the same thing we did here. But don't say you want to make things easy for yourself and just use what we did here. Exactly, inside here. My old man will reach like that. Yes. So use what you have as your measurement. But see, by the time you check, this thing is, see now, 2 centimeters should be 2 centimeters times the 10 points I have is 20. Now if you do your own 1.6 and that 1.8, if you sum your own up, it's giving you around 16 point something. Now if you divide it by 2, it's not giving you 8.1. Our own is supposed to be 20 by, if you do 2 times 10 is 20 now, but we are using 10. The reason that if you do this thing like this. So if you actually count down your own by as it is like this, taking the 2 boxes, taking the 2 boxes, taking the 2 boxes, what it means is that that thing is in a row of, using that your 1.5, in a row of 8.1. That's the point I'm trying to make. So instead of you dividing by 10, when you are doing your own, you are dividing by 8.1. Yes. You are dividing your highest one by 8.1. So use your graph as it is, but learn from this, then you transfer. Okay, who gave me the pencil? Okay, vertically. Vertically is we check the measurements. So please, let's be fast. Let's try. I just want us to be able to answer those questions. Then we'll do our go. See. Yes, under 0 points. Chevy, we started with what, Joe? Please, hello, look, are you looking? Yes. 0.70. 0.70, Chevy? Yes. Other than 0.70, are you saying we made our own such that it even touched to the highest point? Yes. Hope you know that this thing is risky. Yes. Are you aware? Yes. It's very risky. I am watch. You can see what it means. Are you seeing it? Yes. So, but guess what? In physics, it is recommended that this is how you go about finding skill. It is risky, or should you hear me say it's risky, but it is expected that you go about finding skill this way. Whatever you have, divide it by the highest point. So please, for you that your graph is that way, notice that I said somewhere that when you are doing your own, whatever you have, you are dividing by 8.1 because of how we found your graph to be. So now, let's check again. I have watch, please. I want us to see if we can hurry. And finish this. I have, look now, on my vertical axis, I have 4.07. Chevy? Yes. Times 10, let's go minus 7. Do I have anything like, look at, this is where I have something like 10 raised to the power minus 7, Chevy? Okay, but notice that this is 1.04. And then I have 1.144. Sherry? If I check, please watch. No noise here. Please, if I do 1.44 times 10 raised to the power minus 7 minus, I'm just trying to check something. Minus 1.04 times 10 raised to the power minus 7. We can just do it by multiplication, but let's see the visual or mental aspect of it. Do this minus for me, let me see what you have. Is what? 0.40. Times again. Is it minus 10 or minus 10? 7? Okay, see again. Okay, that means that if I add 1.04, if I add this 1.04, I am getting the Sherry. Divide the golden me now by 2. Let me see what you have.
This one.
0.20 minus 7. Mwasi, do for me 1.04 times 10 minus 7 plus 0.20 times 10 minus 7. Let me see what you have.
Hey.
If you like, don't open your eyes.
So my eyes go
1 point. I said 1.04 times this, add this to it, what do you have? 1 point times 10. Do you know what I'm trying to achieve? I'm trying to achieve 1.07. Now let's do it again. This thing I have here, divide it by 2, let's see what you have. I'll still teach you the right method. That is the simple method. You have what? 0.1. That is 0.10 now. Times 10 is power. If it's confusing you, fear not, I'm coming. There are boxes in between each. I'll tell you what that box is doing. It's the same thing that box is doing that we are trying to show you here. When we now go to those boxes, you now see. If this is 0.1077 times this, please go and add this now to this. Just do 1.04 times. 1.14 times what? Minus 7. Okay, this is what it's giving me. That means I still need to divide by 2.
0.05.
Do you know my own? My own is, are you following? No! See, because when we finish this, I now show you what those boxes are doing. Then you don't have to do this again. See, it wants to divide by 2. I should start again from the beginning. You are just opening up. 0.0. 5 times. So remember the goal, the idea is not to do guess what. I see. Do for me.
Do for you.
1.74 times 10 minus 7 plus 0.05. Do it for me. 1.009, Sherry. You're giving 1.0. So you see, gradually I get in there, Sherry. Okay. That means it's not this one. You will come again. You will see that you're going to. Divide this by 2. Sherry, you see it's stressful, right? Divide by 2, don't worry.
0.02.
So to give you 0 points, that is 0.03 now. Times 10 power. Please, do for me 0.03 times this. Add it to this. Maybe you've gotten it. You are see. I see. Which one? 1 point again. I wrote now. Okay, it's all 9. No, it's 7. You can see. Shebi, see how stressful this thing is? This thing is very stressful, right? Now see. Count for me. Pay attention now, pay attention. Between this box and this box, shall we know this thing? For here to we not send it to be 2 centimeters, right? And inside 2 centimeters, I have 10 boxes. Is it 10 boxes? Or 20? Check, oh. Let me look at it. Okay, that's it. Okay, please, do this thing so that there is no error. Hope everything we need here, you all calculated it well before we arrived at this. You are seeing, I see. I am seeing.
So I'm not seeing.
You are sleep. I am sleep. Give me your calculator, let me check something. Yeah, go on, let me check. Now, what we are trying to get is this, is it not? 1.07. Okay, so please, relax. When I have this minus this, what do you have?
0.03.
0.03. I have 0.03. That is times 10. This one minus 7, is it not? Relax now, relax. So I have 0.03 times 10 raised to the minus 7, right? Now, notice that by the time I do whatever I have here, addition to this, it will simply give me what? Is it not true? And how do you know? How do you then know which line to put it? Do you remember that I have 10 lines there? Sure, you know I have 10 lines there. So if you divide those 10 lines by, if you divide, what am I saying? If you divide from here to here by 10, I'm going to be having how many? Please look for me. Each of the box from here to here is 1.04 times 10 raised to the power minus 8. Is it not true? Yes. Divide it by 10 for me.
1.04 times 10 raised to the power minus
1 point.
0.04 times 10 raised to the power
Times 10 raised to the power minus 9. You see what you have? Okay, you divided from here to here, which is this, by 10. He gave you this. That means that each of these boxes is that. So please, what you do for me now is to say, now that I'm here, do for me this thing times this. Do for me 1.04 times 10 raised to the power minus 9 times this. Should you know that what we are trying to run away is guesswork? We don't want guesswork. That's the essence of this. Do for me 1.04 times 10 raised to the power minus 9. 1.0. Give me. Let me put it. Market people, will you keep quiet? I'm coming. Please, check one. Is it this thing you got? Divide this. Divide this by 10. Tell me what you have, please. I think for your own calculation. So please, see what I did though. See what I did though. I said, please, that's the noise. I said, instead of you doing this minus this, and then you start doing that division that we're doing. I said, simply do this particular value that I have here. That is the one I'm going to, what I'm going to. Because I've noticed that after 1.04, I should have 1.05, 0.06, 0.06 before getting to this. And I said, minus where you are going to from this one. And when we did that, we got this. Which means that what I'm to add to this thing is simply this. Now, yes, which means that what I'm going to add to this now is simply this. Are you saying it? I will ignore, please watch. I will ignore this. I will ignore this. Do you know why? Both of them are already in this frequency. Are you seeing it? So when my eye is simply going on this, if I have my meter rule, watch you, please. That's the problem that we are having. I have this to be 0, 0.1, 0.2, 0.3, 0.4, 0.5. Now notice something. Do you remember? That is that thing I said you should check for me. Now this is the same thing I'm saying. Do you remember? That is from 0 to this now. It's the same thing as this. Or your meter rule now. Your meter rule is the same thing as from here to here, this thing now. What I'm saying is, how do I now get that 0.03? How do I now get the 0.03 from this? So I'm saying, if each box here is 1.04 times 10 raised to power minus 9. That means, by the time I add this same thing to this, please check for me what you have. Like each line here, each point here, one of it is this thing. Because it's 10 points now, and we've divided it and we've got that each one is this. So add this to this now, add this twice, what do you have? 2 points. 2.08 times. Okay. Add again, what do you have?
So what are you
Do now, just do. I don't want you to do, you just pick a point. Just do for me. Add this to this thing now. 3.1 here. I do it, continue please. 4.16 there. And 7 is for what? Add now, add, be fast. Add again. Okay. 7. But if you notice, we've already crossed the benchmark because at this point I am having 0. Hoping I am having here 0.104 whatever. Hope you know. Am I going too far? I said this is 0 now, Chevy. Yes. Plus 1.04 times 10. Let's go minus 9. And remember I have 1.04 here. So I have 1.04 the 0 mark plus this. It will give me something. This is another on that. And I have 1.04 plus on this mark I have plus 2 points. And remember this one is having times 10 raised to power minus 7. So I now have again on the other end, I have 1.04. This mark is taking this times 10 raised to power minus 7. I'm teaching you how to get it. Then times, that's because you're not paying attention, times the third point, 3.12 times 10 raised to power minus 9. But please, add for me, add for me. Add for me, this is. You're adding, sorry. Look for me, 1.04 times 10 raised to power minus 7 plus 2.08 times 10 raised to power minus 9. See now, see what I'm saying. See what I'm saying. This one is already on 1.04. This is already on 1.04. I have to pull out all the things it has since it's having individual one. I now said, let the 0 mark here be replaced by this 1.04. I've replaced it. Now, if I add the first one with that 1.04 times 10 raised to power minus 7, Naturally, looking at it, I already know the one I should pick, but I want you to do it practically. I've seen that 0, 4, and 3 will give me the 0, 7 I'm looking for. But you still have to do it this way, using the procedure. So do for me. This one now, 1.04 times 10 square minus 7 plus 3.12 times 10 square minus 9. What do you have?
4.16 times 10 square minus
1 point. I said 1.04 times 10 square minus 7 times plus 3 point. Hope you know that this 3.12 that we are dealing with here is actually a line broken down now.
Yes, and I'm telling you that 4.1.
What did you get? That means you are not getting it. These individual things that we have here, we divided this into 10 now to get it. Oh, give me a calculator. I did. So we go 1.07. You should get 1.07. Yes. So see, please, see my point. My point I could have said, instead of going through this, in between here, pick any point. Somebody said, How does your is not what we need in practical physics? Because somebody very wicked can be able to look at it, take it serious and observe that the point you are picking is wrong. So what I'm saying is that each individual line here, as you mark these things out, automatically, looking at this step, your mind should tell you that the one that has 3 and 4 should give you the 7 you're looking for. So this is the point I'm picking, this one. This is the one I'm picking. So I will come here, let's say this is the first one, the second one, the third one. That means this is the point I'm picking. So I'll project this point. Can I come in?
Yes, sir.
Hope you know you don't know man more than me. So if I want to say pick this one, I should pick it correctly. But what I'm picking is the fact that you write some of these practicals as exam. So you just learn the basics how it should be. That's the point. If I projected a point here as my 1.07, that 1.07 happened at 0.60. Watch. This is 0.63, Shemi. I will come again. I can just say in my eye, I can just say looking at it, let me pick somewhere here. That's the manner for you. But because you are writing this as exam, I said do things well. In between the 2 centimeters, I have 10 points, Shemi.
Yes.
Let me divide. And remember that from here to here is 0.07, right? I'll do 0.07 divided by 10. What do you have? 0.00. 0.00. Is it what you have?
Yes.
That means that if the box from here to here is like this, and this one is 0, this thing is representing as 0, is representing 0.63. Hope you know.
Yes.
And this one is not representing, sorry, it's representing 0.6. And this one is representing 0.63. What I'm saying is, each mark here will have 0.007. I'm not saying add another one to it. So it's what I'm saying 0.007 times 2. 0.00. Is this what you have? I have this 0.007 times by 3. 0.002. by 4. 0.02. Okay. It might be boring, but if you learn it, it becomes easy. You don't have to be stressed again. With your eye, you can now know how to do it. Times by 5.
0.035.
0.035. Well, times 0.007 by
0.042.
Okay. Okay. Times by 7.
0.049.
0.049.
Yes.
Okay. Well, times by 8.
0.056.
Okay. Automatically, I see that this is approximately 6, Chevy. Is it not true? This is approximately 6. Now, see what I want you to do for me. Do for me 0.56 plus 0.049. Let's see what you have. Let's check.
0.609.
0.609.
Yes.
You see what you have?
Yes.
This is 0.56 plus 0.049 plus 0.60. Okay. Do for me plus 0.4042. What do you have?
0.602.
602. It falls within that range. So that means approximately 0.60. But before I use this one, let's check something. Do for me 0.56 plus 0.35. Let me see what you have.
0.91.
0.91. No, it's actually 0.35. This thing. I do for you. 595. 0.5. Which is 0.60, should be preferable. So preferable. So that means that now let's check something. Let's check something. I have 1, 2, 3, 4, 5. Should we? That means the point I'm going to be choosing will be the first, second, third, fourth, fifth. On the 5th point, that's what I'm projecting out. Somebody will say, look at how they are wasting time. It's well.
It's no matter of wasting time, just that it is.
You are doing what?
It's confusing.
It's confusing. Are you writing this in now? Okay, you are doing it. That way you normally do it, I know it, but what I'm teaching you is the standard of doing it. You should understand the standard if you are paying enough attention. Because there's nothing strange we are doing. What we are doing is simply, if I know that this is 0.56, the next one is 0.63. Before this, I should have that 0.60. It's not you're not understanding it. Do you know that it's not when you use your hand and hold your head that you say you have to learn something. Naturally, there is a way you start to tell yourself, can't you cover myself? You start to follow. So you don't just let loose and take it to enter. So you just organize yourself to the enter. What we are doing is not hard. So pay attention if you do not understand this, or we'll do the next one, see if you can understand it. So this, please, hello. If you are not interested or you're seeing the opportunity of the practical as an opportunity to talk, hello, you are disturbing my class. If you see this as an opportunity to talk, we'll stop the practical and do another thing. Please. The reason why I'm taking my time to do this thing, it's not like it's part of my skill. Because now I'm supposed to teach you the practical. Solve the questions. The graph, you know how to do it. But I'm doing it because of the fact that some person come to the DM to ask how do I plot graph. So please, if you will be disturbing my class, we'll abandon it. Ask. Okay, I am.
So we wanted to find the number of boxes now. The way to move from like a certain point to get to like the actual value.
To what?
To your actual value.
Yes.
Instead of finding the approximate number of points you need to, you can calculate the number of boxes. So once you get to that point, the point of the graph, use that certain number of boxes to get to the value that you're getting on graph.
It's still what we are doing now. It's still what we are doing. Why I'm demarcating the line, see what I'm doing, see what I'm doing. What you are doing, what you are saying, is more like when we are not saying it. What we are doing is simply, we already know that, for example, if I'm looking for 0.60, that is in between 0.56 and 0.63. So I'm not just pulling the box out to now find the exact point we are looking for. Are you getting what I'm saying? So that's part of maybe doing multiply is still there. But what we are doing is the practical aspect of it. So I just pull out where it is in between. So please, if you did not follow this one, pay attention to the next one, see if you can get my point. So as we now move to a point where we now understand these things, now you see that it will be easy for you now, no longer checking this thing on your own. Naturally, you can now be doing, if you get the point, your times. And that is it. So, but for now, please pay attention. The next one I'm going to be doing is 8.94. So please watch. If I'm doing 8.94 and it's on the vertical axis, should be? Now notice that 8 actually falls in between. Should be? I just pick it out. Now I'm saying, what I will just do, in order to make things less stressful for myself, is to simply say, where am I going to? I want the point of 8.94 times 10 raised to the power minus 8, should be? But this is what I have here. So I will do minus 8.32. So times 10 minus 8. So minus this from this. What do you have? 0.62 times what? Do you know what this thing means? What this thing means is that if I carry this thing and add here, I will get this point. That's what it means. So what I'm saying is, that point you want to get, which is 8.94, is no must is here, because it's already here. But it's no must is among the things you pointed out in your state. So we are going to minus what I have here. It will give me this. Whatever it gives me is the sentence I'm saying, what I have here, plus this, gives me the point I'm looking for. The minute I get that, I will now remember the number of points in between this. Is 10, shall we? So if I have 10 points in between this, what I'm now going to be checking for is to ask myself, how do I move from here to get 0.6? Let's say I call this thing 0 now. How do I move from 0 on those 10 points? On those 10 points, where is 0.62? Because everything is already raised to the power minus 8, raised to the power minus 8. So between, if this is 0 point here, where is 0.62 here? Where is 0.62 on this? So I will simply say, you said, somebody say multiply what? You divide this now, I'll divide this by 10. So if I divide by 10, we've already divided by 10 and we've got something. Can I clean this now? So if, let's say this is this from this to this, let's say this is 0, and this 0 is set as 8.32 times 10 raised to the power minus 8. Don't worry, as you learn it, we won't be doing this thing again, but learn it first, so that you are watching at this inside your graph. So 9.36 times 10 raised to the power minus 8. But you see, I have 0.1, 0.2, 0.3, 0.4, I have this. Even when you learn this thing, you start to tell yourself there are different shortcuts you could have used to even do this thing. But the main thing is the foundation. Without that foundation, it's too easy for you to learn all those shortcuts that are to come. So now that I have this, what I'm now saying is, if I divide, remember that from here to here is this thing. This is actually what determines this for today. So if I divide this thing by 10, what do I have? Minus 10, shall we? So if that is the case, that means that this is 1.04 times 10 raised to the power minus 9, right? So when you do this times 2, what do you have? Please give me, because accuracy is important. I have 3.12. I have
4.16.
Notice that this is 3, Chevy.
Yes.
Okay, alright, let's go. This one will come
5.2 times 10 raised to the power minus 9.
5 points.
2 times 10 raised to the power minus 9.
Okay, I do for me. Do for me now. 8.32 times 10 raised to the power minus 8 plus 5.2 times 10 raised to the power minus 9. What do you have?
10 raised to the power minus 6.
Cool down point check. 8.32 times 10 raised to the power minus 8 plus 5.2 times 10 raised to the power minus 9.
4.32 times 10.
Okay, give me 8.84. Okay. Relax. Okay. It's supposed to be. Shebi? I am.
If we make it like instead of this 1.04 times 10 raised to the power minus 9, we'll make it 0.104 times 10 raised to the power minus 8. Then we are going to be adding it 1, then you see that it's the end of the 6 box.
Okay, that's what you did.
Yes.
Just whatever you are doing, be doing this what we are doing too. So see, do you know that if I'm the one plotting this graph, I won't do any of this. But the truth is that there are foundations that if you get, do it over and over, you will not be discovering things on your own. And that is what I'm giving you here. As you progress, you'll not be seeing things. So what you're doing might not be wrong, but remember this one too. Okay, now see, let's do it again. Let's do this. And do okay, now please, do for me. 6.2. Do you know what I'm checking? The minute I get to a point where I'm seeing that some of something starting this, and the other one might give me that thing I'm looking for the other side, I'll start adding. So 8.32 times 10 raised to the power minus 8.
8.94 times 10 raised to the power minus 8.
So I'm getting 8.94, shall we?
Yes.
That means I've gotten what I need. So it's at 1, 2, 3, 4, 5, 6. So at the 6th point. So I'm going to be having this 1. Okay. This is 0. 1, 2, 3, 4, 5, 6. Yes. So on the 6th point this way. On the 6th point. Can I claim? Yes. So now let's go to the, when I have this 8.94, I have that here, 0.50, shall we? Yeah, now, 0.50. So what I have here is 0.49. If I want, well, let's check. Let's check something. Let's check something.
Check again.
Please check.
Sherry will say that divide this box by 10 is 0.0. You see what we have? But please, but add the 2, let's see what they have. This one cannot stress us. 0.49, which is approximately
0.5.
7. So the first point there, Chekume said just shift your hand.
Yes.
Alright. So I now get this tune. I'm not using ruler now. For you, as you're doing your own, make sure it's straight. And please, make sure the lines are faint lines. Some people, everything must be thick. Some people's graph book, if you look at it, you'll be wondering if it's pure water they have got on the graph. Because the thing will be looking like charcoal, very wet. Please, make sure it's very neat and clean. So for those of you that you will go, they'll put -22 for you. It's because of neatness. So make sure the work is neat. So now let's go to the next one. We have 7.15. Shall we? 15. So notice, this one is 7.28. That means it should fall in between these two. So please, that means this first set is 0 mark here is set at 6.24. Times 10 raised to the power minus 8. Then I have down to this point, which is 7. So one thing about practical is that it's the easiest. Because yes, why I say it's easiest is just construction. The only reason why it looks hard sometimes is when you've not come to properly understand it. Like for some people, they will be shouting viscosity. But if you check it, using different persons' method, you see that once you get to it, it's just one particular thing you're doing here. So it's not hard. Now see, this box from here to here, we've all agreed that is this thing here. Shall we? Yes. Nice, into 10. So let's divide this into 10 pieces. Alright. Alright. So this one is minus.
That raised to power minus.
And we did, if you do this is from here to this point is 1.04 times 10 raised to power minus 8. Should you agree? Yes. So we are saying this is the value. We added this thing now 2 times and we got this one. So we are saying if from here to here there are 10 boxes inside. So if you divide this by 10, we get that. Please always ask your question, so you don't go home and say you did not follow. I want you to always understand. That's the truth. So 1.04 times 10 raised to the power minus 9. Then I have 2.0. Shebi, please check for me, am I correct? What about this one? 5.9, shall we? I see. 5.2. Okay. I see. See, at this point, this thing we are doing might not look interesting, I know. But if the training is not conspicuous, how will the work not be? So I see. At this point, I am seeing 6 plus 4 gives me 1.6 plus 4. 6 plus 4 is 10, shall we? Now do for me 6.24 plus 4.16. That is 6.24 times 10 raised to the power minus 8 plus 4.16 times 10 raised to the power minus 9. What do you have? 4.0. See, I said 6.24 times 10 raised to the power minus 8 plus 6.24 times 10 raised to the power minus 8 plus times 10 raised to the power minus 9. Do it.
6.65 times 10 raised to the power minus 9.
6.65. Well, leave this one. Do for me. 5.20 times 10 raised to the power minus 9. I will still post this video on our paid tutorial group so that you watch it. What I'm teaching is what we call the standard method of doing it. Anything that we start doing as we progress is now what we call advanced level. The standard. We'll now be doing our. If you do this thing plus this, what did you get?
6.76 times 10 raised to the power.
Okay, count by 6 points. Let's continue. But come, don't worry again. Let's continue. Do for me. This 5.20 plus 1.04 times 10 raised to the power 9. What do I have the next point? Okay, what I ended. 6 points.
2.4.
Okay, but I add this same thing. Each line inside here with the sentence as saying this thing to here divided by 8. So I'm adding this to each line. Okay, Ryan, what do you have? 7 points. 7 points. If I add to this thing, what do you have? Hope you're not tired. No, 6.24 times 10 raised to the power minus 9 plus 7.28. Okay, now I'm seeing do for me. 6.24 times 10 raised to the power minus 9 plus 6.24 times 10 raised to the power minus 8. See what I'm saying? This 6.24 that is here. And add this one to it. Let me see what you have. This 6.24 times 10 raised to the power minus 8 here. Add 6.24 times 10 raised to the power minus 9 to it. Let me see what you have.
6.84 times 10 raised to the power minus 8.
Okay, well, do for me. This 6.24 times 10 raised to the power minus 8 that is here. Add 7.28 times 10 raised to the power minus 9 to it. Let's see what you have. 6 points. Okay. I have 7.28 times 10 raised to the power minus 9 plus
6.96.
But I have forgot there. See, I'm saying now. Go back to this line. Add to this thing that I have here. This value. Chicken soup. Obviously. 8 points what? 8 points. 32 times. Okay. I now do for me. 8.32 times 10 raised to the power minus 9 plus this 6.24 times 10 raised to the power minus 8 that is here. 7.072. Alright. Okay. If I do 8.32 times 10 raised to the power minus 9 plus 1.04 times 10 raised to the power minus 9, do it for me. 9.36. Please add this. 7.1. 7.176. So if I add 9.36 times 10 raised to the power minus 9 to this, you get you what?
7.177.
When you added this one, what did he give you? What did he give you? Okay, from who the government I took that you. 8.32 times 10 raised to the power minus 9 plus 6.24 times 10 raised to the power minus 8. No. You people are not even here. I'm saying, I said before the 9. Out of 10.32, let's check it again. When you added it to 6.24, what did you get? 7 points. See, do for me. See what I'm asking you. Which one? Okay, and what we are looking for is this one. So and you need this one. Like for this instance, he gave you what? I just want to be sure of something. 7.17, Jerry. That means that in between here and this, remember, sorry. Yes. Jerry, is this one that is this now? So in between these two, I should have my 7.15. I have this is what you do for me now. Remember that. Which one? Punch. See. Leave assumptions. I want you to be using your calculator here. When you did this one, you got a value less than 1.5. When you did this one, you got a value greater than 1.5. That means it's in between these two. So I'm saying, remember that each graph from this end to this end is actually 1.04 times 10 raised to the power minus 9. This thing, remember, divided by 2. 1.04 times 10 raised to the power minus 9 divided by 2. Please, we are not ending this class with practicals. I posted 11 to 5. Shebi? 11 to 5. All students will go home. I see. Calm down. Have you divided this thing by 2? 0.52. Please see what you do for me. See what I want you to do for me. Do for me. 0.52. See what I want you to do for me. Do for me. 0.52 times 10 raised to the power minus 9. Plus 8.32 times 10 raised to the power minus 9. Do it. 8.84 times 10. The truth is that once you are doing it by this standard, do it like for almost all your practicals. Use it as your practice. Once you learn it, it will be easy for you. You can look at it then and say this one is this one. Oh yeah. Now do for me. 8.84 times 10 raised to the power minus 9 plus 6.24 times 10 raised to the power minus 8. What do you have? 7.124. Chevy, you can see, let me note it. So don't start shouting. Chevy, you know we did what? Chevy, you know we did. Can I clean this?
No!
But I can clean this one. You remember we did these two, and you got what? Tell me what you got.
7.1.
No. Like this one now. You summed it up and you got 7.1 to Chevy. 8 points. 8 points what now? 8.84 times 10. Raised to minus 9. Chevy? Notice that we divided this thing into 2. See now, see what it means. So see what it means. If I have this now and I divide it into 2, from this end to this end, is that 0.52? Hope you agree. Do you agree?
Yes.
And from this end to this end is still the same 0.5.
Yes.
You agree?
Yes.
So please, do for me 0.52 times 10 raised to the power minus 9 divided by 2.
Minus
0.52 times 10 raised to the power minus 9 divided by 2. You got 2 points. So you got these two to give you this, shall we? I add this now. Add this. 2.6 times 10 raised to the power minus 9. 10 raised to the power minus 10, sorry.
9.4 times 10 raised to the power minus 9.
9 points.
4.
Wait, let me write it here. We got 9.1.
Times 10 raised to the power minus 9.
When you now get home as you're doing all, you can be doing all those, you look at it, but please, if you really want no problem, stick to this pattern where you master it ahead. I now see, this 9.1 times 10 raised to the power minus 9 plus 6.24 times 10 raised to the power minus 8. 7.14. Which is
2.15
okay, that means that the answer we are looking for is actually here.
Yes.
There is one after it.
I didn't hear you.
There is one after it.
7.15 times 10 raised to the power minus
8.
So this is 9.1 plus 6.2.
I didn't hear you. Yes, and half of it. You are doing half of it now. Do you know that if you're not doing this thing this way and you want to use a manual, there are some people that will just look at this where they're actually speaking for their own somewhere here. Another person can just look where the person is speaking is somewhere. So it's better you use the standard. When you master it, you can now be multiplying.
So did you do 9 plus 1 times
I didn't hear you.
plus 6?
Come again.
I said, did you do 9.1? That 9.1 times 10 raised to the power minus 7. Minus 9 plus 6. See what you added?
Yes. Reason being that anything I have to do in order to get 7.15 was 4 in between this place. So I've gotten a value, and when I did that, by you paying attention to what we've done so far, you see how we divided, and we got to that point. Here we now arrive at 9.1, then add it to this. You are testing whatever you have with that. Please, the essence of this class, the reason why we say you pay attention is so that when you go home, you practice. If it's not clear to you, then you go home, you practice. As you practice it on the first graph, practice it on the second graph, suddenly, you are now starting to see our next class, our next graph class. This is not the method we're using. Suddenly, you now start to see what is to come, how you should be going about it. You now start to see that instead of dividing, you can also be multiplying.
Sir, please, I want to know, like that 9.1. Can you tell me why you wanted to reach 9.1?
Wanted to reach 9.1. We were not trying to reach 9.1. What we are trying to reach is 7.1.
Yes, that's why did we not reach 9.1?
Yes, now we stopped at 9.1 because by the time we add it to this, that's what this was.
Giving us that 7.
Yes. Now please, the next thing you are checking for me, please watch. I'm going to count the points. 1, 2, 3, 4, 5, 6, 7, 8, 9. Shall we? 9. Wait, so 8, shall we? Then the 9th one, you see that? So in between, see what we have. Listen. Hello? We have local clubhouse.
Yes.
Please. In between, we have 8. Then in between the 8th one and the 9th one, we have half of it. This is where we have another half. So that is what we have. So that's the point we are picking. So let me do it here. I have 1, 2. You know, you're not the one choosing it. It's already marked out in your own graph. So your own is to locate the 8th point. Select the half. Select the other half. You must learn a lesson. Hello? Always eat before before coming. I told somebody come with your stomach. The person came to me this morning and said, "Sir, why did you say we should come with our stomach?" Yes, sir. So that you will be strong enough till we finish the class. Hope you know that sometimes you think your condition is too bad. It's because you're planning. You're not planning well. You will say it's because you don't have money to buy this one, buy that one. No, buy upper. Ordinary upper. I saw one girl buying it per year. And by now that girl is tired. I told her, why don't you buy upper? So plan your things well. Always eat upper. And then say it will carry you. I see, now see. See, Shebi have gotten 7.15. Now the next thing is to get 0.40. That means it should fall here. It should fall between here. If I want to do manual, I can just say before this, let me pick this, but I will not do that. See what I will do. Each line here, Shebi we said that this is divided into 10 equal parts, right? And we said that each line is 0 points. Shebi, what I will just do is to say 0.42 minus 0.007. 0.42 minus 0.007. 0.41. 0.413 minus 0.007. 0.40. And this is approximately 0.4. Please, if you pay attention, I'll be teaching you different orders of doing this till we get to the final point. So I am starting from the back now instead of moving from the forward, Shebi? This time around. So I'm saying this.
Shift that you
You understand it? Right? So this is 0.41. Do for me 0.41 minus 0.007. 0.4. Well, let's just check something. Let's just check if this should be the last point. Do for me 0.403 minus 0.007. 0.396, Shebi? Which is approximately. Hope you know. See you. Do you know what this thing means? This is if I have. Let me clean this side. Please, all your graph when you start doing your own. As somebody that knows that you don't want to joke with your man, it's okay to hurry. It's okay to rush you. But if you do it over and over, you see that the foundation makes you stick to doing it the right way. You don't have to rush. You don't have to use iron to picking anything. This is the sentence I'm saying. I have this to be 0.42. I remove the first point. And the first point was 0.413, Shebi? I remove the second point. 0.406. Remove the second point. 403. I remove the next one. 396, Shebi? Yes. So I'm using this one. That is from the back. I'm marking out 0, 1, 2, 3. The fourth one. That's from the back, the fourth point. So you people cannot say 35. So you can't say 36. Let me tell you something, man. Do you know, because of the way they have been calling me on your parents' call, we pushed our next class. Let me tell you, do you know when you see who I am? From this month, that is this December, if we fix next class and only 2 people come, That's 6 to 8. Even if it's only 2 people that come, I'll make sure that that particular topic, I will not reteach it. You will see me. 6 to 8. Don't worry. So see, at this point, hope you know that all these things I'm doing like this is that your mind of intersection. Okay, go and do the remaining one and two. No, I'll answer the questions there, but you will go and plot the remaining graph. See, do you know what I will do? What I want us to do? We'll do this last one. You then do this one. Okay, well, let's do it. I see. It's because of the way you are carrying your bag, I'm moving on. But I see, I have 5.20, Shebi? Yes. And after 5.20, I'm having 6.24. I noticed something. What I'm looking for now is 5.37. So I will do the same thing. I'll do the same thing. I'll simply do 5.3. And please, so that I answer this as I'm asking, let's do it 2 ways. Whenever they ask you, what are the errors you encounter? I've told you, we have 3 major classes of errors. First is the random error. Do you still remember? The one that is caused by temperature, wind pressure, that is random error. That is physical, should I say, issues. Physical issues, the laboratory having too much ventilation or less, or things like the pressure, that is the wind and all that. Then the second one after random is systematic error. This one involves your instruments. The instrument, maybe the calibration is no longer visible, or you use the meter rule that the marks are now fixed. Or the vernier scale, as you are using it, you notice that there is slight push here and there. So systematic error simply talks about your instrument. So anytime anybody asks you about error, you are putting your mind in these 3 things I'm giving you. Random error, systematic error. The third one is what we call procedural error. Procedural error, or you call it human error. They are the same thing, almost related. We say that this one is as a result of how the practical was conducted. So maybe you tried viewing the equipment, maybe you are checking meter or the let's say the reading, but instead of doing it directly, you are placing your head from an angle. That's procedural error or human error. Or maybe as you are setting the thing up, you notice that it is not really tight. But because you are trying to make sure you do the practical fast, you did not really check it for time. So all those errors made as a result of your own attention or your own human efforts, we call it human error, also classified as procedural error. So anytime they ask you about error, your mindset, and that human error is where you also classify error due to parallax. Most times they classify it under instrument error too, but it falls between that issue of not making adjustments well due to your own efforts. So 3 errors you always carry in mind whenever they ask you. It is different from when they ask you maybe standard error or percentage error. It's different from it too. So when they ask you what are the outline the errors you encounter, these are the ones you give. Now let's go back to this test. So I have, and I'm going to this test. So I have 5.37 minus, this is where I am, minus 5.20. Somebody will write this thing well, don't it? When he's reading, he will forget that it's minus. You will not say, indeed, this was the essence of this dash. Please, minus. I know students. Like, students can be very funny. Oh, yeah. What do you have?
0.17.
0.17.
Very small.
19. Okay. 9 is now minus 8. Oh see something? I want to get to 5.37. Sherry? 5.37. I'm having. Okay, do for me 6.24. Do for me 6.24 times 10 raised to minus 8. Minus 1.04 times 10 raised to minus. What we know that each line in between this. See. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me do it again. 1, 2. Oh yeah. So do for me. Hope you know that each line here is existing. But do for me 6.24 times 10 raised to minus 8 minus 16. 6 points. Is it what you have?
Yes.
Okay. Let me leave it. 6 points,
6.13 and 10
it's fine. So do for me. Do for me 5.20 times 10 raised to minus 8 plus this thing. Do for me 5.20 times 10 raised to minus 8. Yes, plus 1.04 times 10 raised to minus 9.
5.304 times 10 to the minus 6.
That is 5.37 now. We're using 2 decimal places. If an examiner, very wicked, want to punish you, maybe you make mistake, you are using 2 decimal places, you can use 3 decimal places. You know it's wrong. Once you're using a decimal point, that's what you do. Yes. I do for me 5.30 times 10 raised to minus 8 plus 1.74 times 10 raised to minus 9. 5 points. 5. So the next one is 5.408, which is 5 points times 10 raised to power. Hope you know. Now notice something. Remember that what we are looking for is 5.37. Do you remember?
Yes.
But we've got to 5.41 now.
Yes.
That means that in between 5.37 and 5.41, we should have 5.37. So what do? We now say this thing that is here, because from here to here is this thing. Hope you know. The gap from this, and the gap from here to here is this thing, and the gap from here to here is this. So divide by 2. What do you have? Times 10 raised to minus. Please check. Is it 5.2 you have?
Yes.
Times 10 raised to power. Is it minus 8 or minus 9? Minus 10.
What if you see 0.50?
It's minus 9.
Then you know the shift from like
Please. If you divide this by 2, what do you have? Minus 9.
If you say 0.5,
I did not say if you say, look for me 5. What do you have here? 5 point what? Please, I don't want if. Do this and give me the final answer. Now see this thing that I have here, this thing that I have here, add this thing I have here to 5.30. Let's see what we have.
5.25.
See what I mean, see, do 5.30 times 10 raised to power minus 8 plus 5.2 times 10 raised to power minus 10.
5.25.
Start with 5.35, Shelly?
Yes.
5.35 times
35.
minus 8, right?
Yes.
I assume see, what we are saying. At this junction, you know that box is already very small, is it not true? Yes. For you to do manu, right? But let's continue doing the normal thing. Yes. You don't understand the goal of this. See, the goal of this is to stretch your brain. Whether you are not getting it, you get it by force. Calm down, you will go home. See, you need all the time here. You know why? Most of you, the only thing taking your time is for pressing. So once you are here, but ask. Come down, see. See. What? See. That means, hold you now, in between this. Is that your? Is that for minus the Chevy? So please, you know what you don't do for me. I don't like you suffering. Just come on top. The remaining half. Will I give you 5.3? But if you check it, you will still sing to me. Yes. So what you now do is to project it. Yes. Now let's go to the other side. The other side is giving us 0.30 Chevy. And that means it's definitely going to fall in between these two. So let me just project. Let me clean this. Please. My own happiness is that if you've paid attention so far, by now, you will get the basics of what we are doing. So that on your own set, you can be doing it as fast as possible. Now let's go to, if we do this one, you now complete these two for me. So let's go. So I have everything is 0.0, the line, each of the line is 0.007. So if each of the line is 0.007, that means look for me. 0.28 plus 0.007. Guys, this 0.28 plus one line here, that is 0.007. 0.287. Look for me, that is 0.29 now. Look for me, 0.29 plus 0.007. 0.29 what? Okay, now look for me. 0.29 plus 0.007. 0.30, which is approximately 0.30. That is on the third point. Shall you see the weak are going home? Why will you be going home? You don't know you will persevere. Endure. But you see, so the third point. 1, 2, 3. Now see, it's remaining just one. We can still persevere and finish the last one. Let's persevere and do the last one. See. We'll be fast. See. Let's be fast. Let's be fast. Please. See. Shebi, you know we've not gotten error is slow. And I've told you, whether they ask you to find error is slow or not, you ought to find error is slow. And you know that error is slow is given by 4W over any we'll still do it on Monday. Here we told you this one is vertical scatter. Number of observations here is 1, 2, 3, 4, 5, 6 observations. Shall we? This one is range. That is highest horizontal value minus. Okay. Everything is yours. So I want to get 3.58 in 4 cities in this. 16. Let's see what you have. What's the sheet there? So you have 3 points. No, I'm respecting 2 because that 4 is not to 5. I do for me 3.22 times 10 minus 8 plus this thing. Persevere. Oh wow. Here for you. And I should not say this. 3 points. 3.328. 3.328.
No, 3.33.
3.32. That is 3.33 times 10 minus 8. And 3.33 times so times 10 minus 8 plus this thing.
3.1.
See what we are doing. We are saying here and there, we adding this thing to it. It's
3.43.
If you want to start from here, we'll minus it. In our next class, I will not teach you. This thing we are doing here, you will not be seeing that we are just taking time for you to master it. But if you look at this critical, you can say that if it's 3 lines, and I know that this thing is 1.04, I can say times 3 lines. Whatever it gives me, add it to this thing. We'll still get to that point. But for that, I do for me the next one. 3.4. And that is 1 minus 8, shall we? That means 3.37 falls in between this and this, shall we? You see that it is very tiny already. Is it not true? It's very tiny already, shall we? Do you know why I'm not telling you to do, man? Because you've gotten to the point where you mastered what I want you to master here. It's 3.8 you are doing. Okay, it's 5.37, shall we? Can you remember never? Shall we 3.58? Okay, and we've got to 3.43. Okay, sorry, we're still going up. Okay, the first one will be 3.5 times. Okay, now add is something to do. Now, so this, add this again. Okay, that's the 5th one, shall we? The 5th one is 3 points. Now, notice something. Now, notice something. See what I want you to be doing now. See. Naya, can you look? Look. Can you still see? See. The summary of today's class is that to find the points, if you notice, like for example, I'm doing 3 points, I'm doing 5.37, shall we? And, sorry, I'm doing 3.58. And I'm actually at 3.12 is the 0 mark. That means if this is 1.04, I will just do 5 points there because that means that I should get it if each one is around 1 point something. Yeah? So I will just do the 5th point times this thing. Can you see it? Assuming the line maybe is giving me 2 point something. Maybe 2 points. And I see that I'm going to like let's say 5 here. That means 2 times 2 is 4, shall we? Now, 2 times 2.5 is around 5, shall we? I'll just do that 2 that I have here times 2.5, that is 2 lines and half of it is going to be giving me something close to this. And that is my point. That's the shortcut. I don't know if it's clear. If it's not clear, please, if it's not clear, we've not said anything about it because that's the one we use on Monday. But let's finish this one. Now see, this one I'm not having 3.54 and I'm having 3.64. But what I'm looking for is 3.58. Now, if I have 3.58, notice so what I just need is 4 points. Guys, 4 small points. And I'll have 5 heads. I'm missing out. Yes. That is 3.54. Guys, times this. Plus maybe another anything, maybe 0.04. So, should give me something of. What I'm now saying is, since 0. Let me do this in a clear place. So I have here to be 3.22 times 7. Sherry? I have this one to be 3.33. I don't want to be putting times 10 raised power 8 again because all of them are exact answers. So I now have 10. 4. Sherry? 6, 4. Going on. Is it not true? Yes. What I'm saying now is that in between here, we will check it too, so that you confirm what I'm saying. Remember, I taught you the normal method, game one style. Now, if I come here now and choose this, by the time I do, check this one. This is 1, 2, 3, 4. Is it not? 0.5. Do for me 4.5. 4.5 times 1.04 times 10 raised to power minus 9. I will repeat. Only Jesus can come again. Please, what we are not doing at this point, see, this is not manual. What we are not doing is what we are supposed to have done in the first place. But you needed to learn this one. I am saying, count the number of points here for me. This is 1, Chevy, 2, 3, 4, 4.5, Chevy. Look for me, 4.5 lines, 4.4 lines times each line there is what? 1.04, Chevy. Okay, it's 4.68. Is that what you have? Okay, one say again. This is what? 4.68. That 4.68. If I have 4.68 plus, where are we set? Plus 3, see where we are. Plus 3.12 times 10. Shall you say you did this and you did 4.5 times 1. Chevy, people that left already, they can't remember this one. They can't tell of this one. No, you got everything here to be what? Like, what did you get here? 4.68 times. Like this? Yes. Do for me. That thing you have there. That thing you have there. Plus this. What do you have? See, I said 4.68 times 10 raised to power minus 9. Plus 3.12 times 10 raised to power minus 9. 3.588. That is 5.9. 3.59, Shelby? 3.59. And we will go with it. Do you know why? That is approximately 3.60. Is it not true? And this is also approximately 3.60. Hope you know if I round it up. So what I'm saying in essence is all these things we did before now, we are doing it for you to learn. But the best way to know this thing is simply find the number of points in between. And we need the number of points in between here to be this thing, Chevy. If I don't want to get something that is maybe 3.58 or maybe 3.60, it means that since this thing starts with 1, I should be having 6 lines. It should be around 6 lines here. So I will do this times that 6. Now when I do it, I come back and add it to this place. Are you seeing it? Very simple. So that is the shortcut. So let's now stretch this. That means that this should be on the 4.5, Chevy? Yes. So this should be on the 1, 2, 3, 1, 2, 3, 4, 5. So this way, Chevy? Yes. 0.20. The this is our 0 points. This one is 0.07, Shemi. 0.0. Is this 0.07 for each line? 0.007 for each line, Shemi. Now notice something. I am having 0.21 and I am having 0.20. All I need is 0.20. That means it should be from here to here. Is it not true?
Yes.
Before you shift that. Now what I'm doing is to say 0.07 times 10 is what? Is 0.7? No, look for me. What I'm saying, see what I'm saying? Each point here is 0.07, Shemi. I'm not saying, do for me. 0.07 times 9. Let's see what you have. You are not even following. I said, Shemi, this is what to get. See now. This is, from here is 0.14, Shemi. This is, if I do plus 0.07, it will give me something. And that way till I get to 0.21. What I'm saying is, in between here, I have 10 points. In that 10 points, I've noticed that 0.20 is close to this 0.21. So it's almost all the whole points. So I'm not saying, do for me, that's 0.007, like each line is, times 9, that is, okay, that's 0.063. Is it what you have? This is approximately 0.06. Add that thing, 0.06 to 0.14, let's see what you have. 0.203, which is approximately 0.2. Very simple. So at the 9th point, 1, 2, 3, 4, 5, 6, 7, 8, 9. You see, those of them that rush to go home, and their mind will be telling them that this thing is hard, but it's not hard. No, it's not shift Just check the points. Check how far it is from the end. So if you do it, that's the shortcut. But please, know the normal method before this. Now, to get the line of best fit, see now, to get the line of best fit, hope you know that line that passes through this point of intersection is known as line of best fit. Place your meter rule straight. Make sure it touches 3 points. Yes, see. Notice. At least 3 points should enter. Can you hear me? At least 3 points should enter. And if I look at my graph, it's looking very perfect. Do you know why? Whenever you have line of best fit, and one side goes like this, that is the one off the point. And another one goes like this. This one is going this way. It means that my graph is very perfect. Yes. But if you do your own, and all the points enter here, you should be very afraid. Because it means your graph has no error and it's not possible. So please, on Monday we continue. So somebody should pray for us. Okay, somebody pray for us.
In Jesus' name.
We know.
No, Pastor.
Yes. Somebody pray for us. Don't worry. I'll send it. You see it on YouTube. Then I'll send it on our page group. Somebody pray for us.
In Jesus' name.
Amen. May the grace. Surely. 5-6 years from now, you come back and watch this video and see how small you are looking. Go home straight. Don't branch. If you've not paid for tutorials, make sure you pay us next week. Go home straight. Don't branch. Take care of yourselves. Yes, welcome, my
I want to do something.